Yeah.
Okay guys, so this is going to be the pre-flight inspection of the PA-28, which is a Piper Cherokee 140. When we approach the aircraft, we first ensure that the park brake is applied and the flaps are retracted. We apply the park brake to ensure that when we remove the chocks before departure, the aircraft does not roll forward. So we see that the park brake is now applied and the flaps have been extended for the pre-flight inspection. We continue by approaching the nose of the aircraft and undoing the Zeus fasteners on the nose cowling for the engine check. Now this is a 4-cylinder normally aspirated engine, and as you can see we've got 2 cylinders on either side which are horizontally opposed, and we ensure that all the spark plugs are properly attached to the aircraft with the spark plug leads, which are fine for now. These are engine baffles which direct the airflow for engine cooling and reducing engine noise. You can see the other 2 spark plug leads below the cylinders, which all attach to the magneto, which is where we have a left magneto on the left hand side of the engine, a right magneto on the right hand side of the engine, which provides power to the spark plugs for ignition. We then proceed by ensuring that there are no oil markings on the cowling of the engine bay, to ensure that there are no oil leaks in this engine bay. We can then proceed to check that all the pipes are properly attached and the electrical wires are all attached as well. Here we see our primer lead also attached, and this primer lead is attached to the primer in the aircraft, where we may squirt engine directly into the cylinders for easy starting on a cold day. We can then check the oil, and we do this by checking that the oil quantity is sufficient for flight as per the aircraft approved flight manual. And for the Piper Cherokee, we need between 6 to 4 quarts of oil. We can see that our oil is now on 6, which is fine for departure. We ensure that the oil dipstick is finger tight. Ensure that the Zeus fasteners are properly locked on the engine cowling. We can thereafter go down to the nose gear. We check for pressure on the tire, and we check for tread, which is sufficient for flight. We now check the split pins and bolts are properly attached, and we ensure that we have a minimum of 4-finger extension on the oleo. Our oleo has got a mixture of oil and nitrogen gas. The oil absorbs the impact on landing, and the nitrogen gas. We now go to the propeller and ensure that we have no nicks or dents on the leading edge or the trailing edge of the propeller, and we make sure that we've got no bends on the propeller. We then come to the landing light and ensure that we've got filament on the bulb. We can now check the second air intake on the left and ensure that the second air intake is clear of any sediment or obstructions. We then proceed to the left hand side of the nose gear, ensure that the tread is sufficient, the bolts are properly attached, 4-finger extension on the oleo, and torque link is properly attached. This is our engine drain, fuel drain, and is located along the fuel line from the left wing to the engine. We ensure that there is no sediment in the fuel which would float to the bottom or sink to the bottom. We ensure there is no water in the fuel, and we ensure that we've got the correct grade. The correct grade can be verified by looking at this indicator on our fuel strainer. And the Piper Cherokee PA28 utilizes a fuel rating of 100 LL. So 100 LL avgas would be bluish in color, and it stands for 100 octane low lead. So we check for sediment, we check for the bluish tinge for 100 LL, and we check for smell. Smell is correct for avgas. We disperse of the fuel. We may now proceed to the main gear of the aircraft. We ensure that we've got a minimum of 4-finger extension on the oleo, which we have. We ensure that the brake disc is smooth and not ridged, which will be an indication of whether our brake pads are sufficient for flight. We ensure that there are no leaks on the hydraulic line, and we ensure that we've got sufficient pressure and tread on our main landing gear. We may then strain the fuel. The fuel drain in the wing tanks are located at the lowest point in the tank, and we are also checking for grade and contamination. We can see that the fuel is not contaminated. There's no sediment or water. If we do find any fuel or water in the fuel, we continue straining until the fuel is clear of the sediment. The fuel drain is located on the lowest point of the tank to ensure that any sediment or water that might have accumulated in the tank is drained from the lowest point. Color, smell is fine, and we may disperse of that fuel. We've got a fuel ventilation line here which ventilates the tank to prevent any airlocks, and we may now move on to the pitot tube on the aircraft. The pitot tube, we ensure that the cover is removed. We ensure that there is no sediment obstructing the pitot vent there. The front vent measures the total airflow, which is a combination of the relative airflow and the static pressure as well, which feeds the airspeed indicator. We also have an integrated static port behind the pitot tube and underneath the pitot tube, and we ensure that the static ports are also free of any obstructions. So there's the hole there below, and we've got a hole at the back. The static port also feeds the airspeed indicator, where the airspeed indicator subtracts the static pressure from the total air pressure to give it only a relative air pressure, which is then translated into an airspeed reading. The static line feeds the altimeter and the vertical speed indicator, and the reduction in air pressure or the increase in static air pressure is translated into an altitude. We now proceed to check the leading edge of the wing to ensure that we've got no dents which would disturb the airflow over the leading edge of the wing. We check the fuel quantity, and it's important that we do a visual check to ensure that we've got sufficient fuel for departure and that it confirms with the indication on the fuel gauges. We've got a little warning indicator here, which is a stall warning, and the stall warning will sound an alarm or a buzzer or a light which is installed in the cockpit, which will flash or buzz when the main wings exceed the critical angle of attack, which is 15.9 degrees, warning us of an approaching stall, and we therefore check that the stall warning is full and free. We then check the navigation lights are properly attached, and we may now proceed to check the flight controls. Check that the ailerons are full and free, that the horn balance is properly attached, the hinges and split pins are properly attached. Okay, so lucky get the hinges and the split pins. We've got hinges and split pins on the inboard of the aileron as well. And we now proceed to the flaps. We have extended the flap when we approach the aircraft, so that we may now extend the flaps further to verify there are no cracks on the flap tracks and the bolts and nuts are firmly attached. So Lucky, get the flap tracks. So the flap track is located on the outboard of the flap. We've got one on the midpoint of the flap. The bolt and nut is properly attached. There are no visible cracks. And we may now go to the inboard flap track to ensure that the bolt and nut is properly attached and there are no visible cracks on the inboard flap track as well. And we make sure we've got a little bit movement on the actuator here as well. I can get this actuator, please. So we ensure that we've got a little bit of movement on this actuator as well. We may now check that all the rivets are in. There are no missing rivets on the airframe. The aircraft is not lopsided, and all the navigational aerials and communication aerials are properly attached. This control surface here is called the elevator. On this aircraft it's called a stabilator due to the entire surface moving. We ensure that there are no damages on the leading edge of the stabilator, on the cowlings, and that the movement is full and free as well. This is called a trim tab, and we ensure that the split pins are on the trim tab and they are properly fastened. We ensure that all 4 bolts are attached, the lever is properly attached, and the pulley is not frayed and properly attached as well. So just make sure, Lucky, just come in, make sure that everything is attached there. Alright, just make sure you get the pulley there, the cable and the bolts and nuts. Have you got it? Okay. Now ensure that all the split pins are properly attached on the trim tab and the leading edges are fine on the stabilator as well. We ensure that the rotating beacon is properly attached and the navigational aerials are attached as well. We can now ensure that all the rivets are in. Then we proceed by continuing our inspection of the flap tracks on the right wing. Flap track is okay, no visible cracks, bolt and nut is properly attached. We've got some movement on the actuator. The flap track on the midpoint is properly attached. The bolt and nut is in. And we check the flap track on the outboard of the flap as well. We can then proceed to the split pins of the right wing aileron. Ensure that the movement is full and free on the aileron as well, and as you can see, the control column linkage to the aileron as well. Okay, you can carry on your Lucky. Ensure that the hinges are in the entire aileron. We ensure that the navigation light is attached and the fuel quantity is sufficient on the right tank as well. We may then proceed to ensure that the air vent is not obstructed. We may now check the fuel in the left tank, and as you can see, we've got no sediment or dirt. Smell is fine, and we've got the bluish tinge, which is required for 100 octane aviation gas low lead. Right, so we may disperse of the fuel. We then continue to ensure that we've got sufficient pressure and tread On the main gear, our brake disc is fine, ensuring that the brake pad is within limits. There are no hydraulic leaks on the hydraulic line leading to the brakes. And that's our pre-flight on the PA-28 visual outside exterior inspection. All right, done.